Hello, and welcome back to my series on building a web server from scratch in C. Last time I was showing you how I have parsed out my HTTP requests into these more usable objects, and I showed you kind of the plan going forward. And I want to first say that the HTTP request object I'm going to call partially finished, because I have gotten the basic process of actually parsing these strings out done, but I'm not really sure how I want the end product to look in that HTTP request, and I'm not really going to know it until I start actually trying to use it. So this will probably be modified, and I would say what I have now is a prototype of the HTTP request. And in the spirit of prototypes, I also showed you what I was going to need going forward, and I created this HTTP server object and have since deleted it because, as I said, that was going to be a prototype. So I want to begin here by actually taking a different perspective on this project. So far we have started with the small parts of it, so the sockets, the linked list, the queue, all of those things, and we have sort of built them up to get the product that we want. But at this point, I'm starting to have trouble seeing what these things need to be like and how I need to implement them because I don't have a clear enough vision of the end product. So what I'm going to do today is actually demonstrate what I want the end product to look like, and then we're going to start actually working backwards. So we will start with an idea of how this thing should actually work, and then we're going to sort of work back to this HTTP request and sort of close the gap as we go. So I'm going to open up this main file, and I want to demonstrate how I want the end user to use my web server. If you saw the previous video, you'll see that that was in a way similar to Flask in Python, but it needs to be implemented in a different way for C, so that's what I want to show you here. So what we're going to do first is actually define a function, and this function is what we are going to call a route. Now, route is just what is done when a user visits a certain URL on your website. So if they go to homodeus.us, that's going to call a certain route. If they go to homodeus.us/users, that pulls up a different route. And these are the functions that are called when the user asks for that route. So let's define an example route. So all of these routes are going to need to return a character pointer. And that is because the route is going to give the user a page, a web page, maybe HTML, maybe JSON, whatever it gives the user. It's going to need to be a character pointer. And then we're going to name this route. So I'm going to call this example. And this is going to have to take a few parameters. First of all, we're going to need the struct HTTP server, and we'll call this server, but it needs to be a pointer. And I actually have deleted that object, so I'm just going to define it up here. And we're actually not going to put any real parameters in it. We'll just say int x. I might add some later. And I'm not actually going to keep this here. This is just so that I don't get these error messages. So we'll see that it takes an HTTP server, and then it's also going to take an HTTP request. So struct HTTP request pointer request. That way I'm dealing with those actual objects and not actually copying them. So this one we actually do have implemented in another file, but I'm just going to create this dummy one here just to keep everything consistent. So HTTP request, and we'll say int x as its parameter. Okay, so that's our basic route definition, and all routes are going to need to look like this. They are going to be a function that returns a character pointer. They'll have some name, and then they're going to take as arguments a reference to the server and the actual HTTP request. That's what every route is going to do, but in the brackets, we can actually specify a lot of different things for this to do. So maybe it connects to a database and adds something, removes something, or modify something in that database. Maybe it calls another website and uses an API for something. There's glare on my eyes. Maybe it calls an API. We don't know what it's going to do in this function, but in the end, it is going to call another function that I will write, and I'm going to call it, it's going to return a character pointer, render template, and this one will return render template. Okay? And render template is going to take a series of arguments for pages. So I could have it just take a single page, index.html or users.html. It would read the contents of that file and just ship it over to the user. But thinking about this from the perspective of actually making a website, that's not very pleasant because the user is going to have a discrete file for every single page. They'll have to have index.html, they'll have to have users.html, admin.html. And that's a tedious thing to do. What you really want to do in your HTML is segment things out into templates. So you can have a header.html and a footer.html. And then the server will actually stick all those files together. That way, if you want to change the header on every single page on your website, you just modify that one file and it'll all still work. So this render template is going to take in all of the arguments for everything you want to stick together. So if you want a header, the body, and the footer, you will say header.html, body.html, and footer.html, and it will just stick all of that together for you. So that's what this render template function is going to do in the future. So this defines our basic example route. Now keep in mind that in here we can do other things. So this route can actually be quite complicated. We can have it do all sorts of calculations and API requests, anything we want. It just needs to, at the end, send the user something to actually look at. It could just be the word OK. Now, once we have that, we are going to need a main function. So these can actually be split up into different files. If you are making a website and you want to have one file that is your users page, then you can put all of the routes for the users page in that file and just import them into where your main argument or main function is going to be. But for now, I'm just going to keep it all in one file, so it's simple. This is just a prototype. So first, we are going to actually define a server object. So struct HTTPServer, we'll call it server. And in server, we are going to want to call this function called register routes. So let's define it in here. So this is going to return void, and it is going to be a pointer to a function called register routes, or we'll just say singular route. And for the arguments, we are first going to want the server itself, and this is in the wrong spot, so let's do it down here. So we want to pass in the server itself. Then we want to pass in the actual route function that we want this to be referencing. So this is going to take in another function pointer. That function pointer is always going to return a character pointer, and it is going to be a pointer called route function. And the parameters of the route function are always going to be a reference to the server and a reference to the request. Okay, now we want a character pointer for the URI that is going to be associated with this. So slash for the home page or slash users for the users page. So we will just pass in a character pointer called URI. And then the next part is a little bit interesting because we want to specify the methods that users can use to access this particular route. So does this route accept GET requests? Does it accept POST requests? Does it accept trace requests? What kind of request does the user need to make on this route? And you can specify a number of them. You can specify one of them. You could specify all of them. So we don't know how many subsequent arguments this is going to take, but we can actually handle that. And what we'll do is pass in an integer that is the number of methods And then we're going to put in ellipses, just 3 dots. And those 3 dots represent a variable number of arguments. And we can programmatically extract those arguments and use them. So this is a way to make your function accept multiple things. It's not quite as simple as it's sounding, and it's not quite as elegant as maybe we would like it to be, but it works. So that's great. So we can accept a variable number of methods for this, and this function is actually going to register that route onto the server itself. So once we have our server object, we can say server.registerRoutes, and then we'll pass it the information we want. So we'll pass it the address of the server itself. We're going to pass it the function we want, which in this case is example. And then we need the URI, and we'll say /example for that. And then we need the number of methods. So let's say we want this to take get and post. So we'll say int, well, not int, but the number of methods we'll say is 2. And then we're going to pass in some sort of code for those methods. And since these are going to be integral values, we can't use characters or shorts or some other variable types for an ellipses sort of thing. I think they have to be self-completing, self-referential. I don't remember the name there, but only certain types of variables can fit in these ellipses. Integers are one of them. So originally in my HTTP request, I had an enumeration of the different types of requests or the different methods that you could use. And I'm thinking I might bring that back and work that into the request. So this is what I mean when I say that this request object is sort of semi-completed or a prototype. So I think that we will use an enumeration to make that a little easier. So we will then register this route. This route will be embedded into the server itself. Then when the user actually connects to the server and requests something, we will use the URI of that request to find the function that we want to run. We will then run that function and send the result of it back to the user. So this is a nice way that we can dynamically create our website. And it also makes for a pretty elegant interface. So you have to remember that all of this will not be in the file, and you can separate these into separate files. So essentially, once this thing is done and ready to actually make a website, we're going to have this really simple interface where we just have to specify, here are the routes, here's what the routes do, we register all of them, and then at the very end we just say server.launch. And that's it. So that is the end goal for this web server. And so what I want to do today is actually go in and create this HTTP server object and see if I can implement this register routes method. So let's create a new file. We're going to call it HTTP server. And we're going to define a struct. We'll also need to include the server object because the HTTP server is going to inherit from our server object. So let's include, I'm also in the wrong file, so let's fix that. So we'll include server.h, struct def, HTTP server. And we know, first of all, that this thing is going to include a reference to a server. So struct server, we'll call it server. And then we are going to want our function for registering a route. So this function, again, returns void, and we're calling it a pointer to register routes. And its arguments are the server itself, and then the function that we want. So pass it the route function, which itself takes the server as an argument, and a request, which we need to include. Protocols, HTTP requests. I'm not sure if that one's actually going to be a pointer or if we're just going to pass in the value of that request. I'm not sure if it will actually matter, so I'm just going to leave it as a pointer for now, and if I decide later, I can change it. So that is our route function, and then we're going to need to pass in a character pointer called URI, and finally the number of methods that the user can specify, and then some ellipses for those methods. And let's also define a constructor. So struct HTTPServer and so far we don't need to pass it any values. So let's open these up side by side, and let me remember to actually increase the font size. I hope that's large enough. And let's open this .c file. So here we want to just define our constructor, and hopefully today we can get our register routes function working. So let's just put these in. I'm going to copy that, and I'm going to copy this. That way I can close that file, and we can have a little more space here. Okay. So let's start with the constructor. Well, actually, let's define a prototype for the register routes function. So that's going to be this one. We're going to put that there. We'll delete the fact that it's a pointer. And there is our prototype. And in this, so far all we're going to need is to define an HTTPServer object and then say server.register routes equals register routes. If I hit enter there, it's going to give me all those parameters, which I'll have to delete, so I'm not going to. And we also need to initialize the embedded server itself. So we'll say server.server equals server constructor. And I'm thinking in the future, I may want to use a configuration file for these specific parameters. But for now, I'm just going to put in some values, and we will just keep it in mind that that may need to change later. So this is AF INET, and then the service is sock stream. Protocol is going to be 0. The interface is, what is it? inaddr any. Port, let's say 80 for now. That's specifically where I think we're going to want a configuration file. I can pretty much guarantee that we're going to use sock stream. In fact, I can because of the way that I'm implementing these. AF INET, you may have IPv6, so that may need to change. So I'm not sure about those, but the port and backlog, you're very likely going to want to access to. So I will probably want a configuration file here, but we're not worried about that right now. Let's say the backlog is going to be 255 and our launch function. I'm not quite ready to do anything with the launch function yet, and I'm actually not sure that this server object should have a launch function at all, because when I actually implement the launch function for this HTTP server, I'm going to want to do that for the HTTP server object, not necessarily the server object. So I'm not quite sure what to do about that. So let's just define something here, and we will just know that it's probably not going to work. See, this takes a pointer to a server struct, whereas the launch for HTTP server should take a reference to the HTTP server struct. So not quite sure what to do there. Let's just put that in for now, and we'll see where this goes. Okay, and then we can just return server. And that's our constructor. So now we need our register routes function. So let's copy this. And what I want to do first is actually go back to my HTTP server object. So what I want is a dictionary of these routes. So we're going to use the keys or the URI as the key, and the value is going to be probably another object that we create. So we're going to want a dictionary of these things. That way we can easily find them again. So struct dictionary equals, no, not equals. We're going to call it routes. Okay, and we'll probably want to initialize that. So server.routes equals dictionary constructor, and our compare function is just going to use strings because the routes are going to be strings. So what did I call that? Compare strings. And we can get rid of the parameters. And is that what we need? Yes. Okay. So we have our constructor completed. We now have a dictionary of routes embedded. And so let's work on actually registering this route. So what we'll want first is to get the different methods here. And I think what I'll do actually is create my route object first. That way it kind of makes sense what I'm doing here and why. So let's create a representation of a route. So a route is going to contain just some data. Struct def route. And this is going to have an integer array called methods. This is why I think that enumeration is going to come in handy. And there are 9 possible methods in HTTP. So this will be an array of 9 values. And I'm thinking that for defaults, we'll use 0 or -1. So initially, all of this is going to be 0. That's how it works when you declare an empty array. Everything gets initialized to 0 for integers. And if I use 0 as a null, so to speak, and I define all of the methods to be 1 or above, then this will work pretty well. We'll also put a character pointer called URI. I know I'm going to be duplicating that as the key, but I think it'll be useful to keep it in the route itself as well. So we have the URI, and then we're going to have a function to actually run. So this is going to be void pointer to, oh, not void, but character pointer to a function pointer called route function. And this is going to take, we need to include those. So HTTP server and include protocols request. So this is going to take HTTP server, pointer called server, and struct, I'm not getting autocorrect anymore, always a good sign, struct HTTP request, we'll call it request, and there we go. Is there anything else I need here? I don't think so. Let me clear out all of this and just sometimes if I build the project, I'll get my autocorrect back, and I'm not really concerned about what it said there. So yeah, see, there we go. Okay. Just pass in void there, and we should be good. Okay, let's return to our route. So our route just has methods that are allowed. It has a URI by which we can access it, and it has a function that should run once we want to actually visit this route. So I don't need to do any, I probably could make a constructor for that, but it's simple enough that I don't really need to. So the first thing we're going to do in this register routes is create an instance of a route. So we're going to need route.h, and let's create an instance. Struct route, and we'll call it route. and we'll say route.methods. Well, we can't actually do that yet. Here is where we need to go through all of the methods that were specified. And to do this, we need a certain include file. So we're going to include stdarg.h. And this is what allows us to actually go through those ellipses and pull out the arguments that we want. So we need to define start arg or arg start. What was it again? Okay, so the refresher of my memory today takes the form of our friend Jonathan Leffler and JBX on Stack Overflow. I can't tell who originally wrote it. I think JBX wrote it and John Leffler edited it. But anyway, what we can see is we import the standard arg function, and then we use VA. That's the thing I was looking for. So VA list. This is a custom data type in that standard argument library. And we use this to define this list of arguments. So we're going to call it methods. Is that a good name for it? Yes, I believe so. Okay. And then we want to define VA start. And this is going to take an access point, so methods. And the parameter is going to be, what is that parameter again? The number of arguments, of course. So here we just pass in num methods. Okay, now we can access these one at a time. And it's not so easy as accessing one in the middle. It's not like an array where I can specify I want the third argument. You have to take them one at a time sequentially. In this circumstance, that's going to be fine. So we can use a for loop. And what we're going to do is use this for loop to iterate through all of those arguments and stick them one at a time into the routes methods. So for int I equals 0, I is going to be less than the number of methods, and then I plus plus. So here we are going to say route.methods I equals VA arg, and then we're going to pass it again methods and int. So this iterates through our methods. So all of the methods that we pass in here, be there 4, 5, 7, there can be at most 9, it's going to take them one at a time. And notice that because we have to use this, we can't actually go to a particular place in those arguments. We just have to take them one at a time. We also have to pass in integer to tell it that these arguments are integers. That way it knows how big they are and where to go to look for them. It's basically like using a pointer. So we need to know where that pointer ends in order to find the next section. So that's how this is basically working. I also want to point out, if you remember way back when we were first doing the linked list, I was wondering if there was a way that I could pass a data type itself as a parameter to a function. And I found the answer was no through my research. But here I am seeing an example of a data type being passed in as an argument. So I would love to know what's going on there. I'll do some more research on this VA_arg function, but if you know what's going on there and why they can pass in a data type as a function parameter, please let me know in the comments. I would love to hear about it. Anyway, this is going to copy all of our arguments over into the routes list of methods. And what we'll do eventually is when the user calls that method using some HTTP request, we will check what method they're using. And if they are using a valid method, it should be in this array. And we can decide whether to continue forward or to reject their request because they specified the wrong method. Okay, so we have copied those methods, and now we need the URI. So we're just going to use string copy. So we're going to need that string library. So we'll say the destination is going to be route.uri, and the source is going to be URI. Okay, does that take care of all of the components? We have the methods, we have the URI, we need the function. So our route function is going to equal route function. And that has initialized our route object. But now we're going to actually need to insert this thing into the dictionary that we have in the HTTP server struct. So we are going to want to say server routes.insert. And what is our insert function again? Let me remind myself just so I don't have to fix it later. So our insert function takes a reference to the dictionary, the key, size of the key, the value, and the value size. Easy. Okay, one other thing I want to point out, I changed throughout the library, anytime I had to pass the size of something in, there was an implicit conversion I was doing because size of returns unsigned long, and I was asking it to pass an integer here. So I just changed it so all of these take unsigned long. Simple fix, it compiled either way, but just getting rid of some implicit conversions. Anyway, so we are going to pass in the address of server routes. Our key is going to be URI, and the size of the key is going to be size of a character array with the string length of URI. Remember from the previous one that I was having trouble getting this size of function to work. So this is the solution that I found that actually will give you the correct size. If you know another way to do that or why that wasn't working, again, leave it in the comments. Okay, so now we need the actual value. So we're going to pass in route and size of route. So that should insert our route into the route dictionary. What did I do wrong? So let's pass in the address of route. Okay, so we will now have our route object inserted into the routes dictionary of the HTTP server. So later on, what will happen is the user will make a request to our server. It will parse that into an HTTP request object down here, and then it will use the URI that the user has specified to search for a route that matches it using the same URI. It'll be stored in this dictionary. And if it doesn't find it, we can just send them a 404. But if it does find it, we can then call the function that we have defined here. And we can just say whatever the result of that function is, just send that back to the user. And we'll have a render template function in there somewhere. But this is the basic design I'm going for. That way, when we go to our main file, which now is empty, I will be able to just define what routes I want, what I want them to do, and how the user can access them. So that is our design. Next time, we are going to continue building this, and I think the next thing will be what? What will the next thing be? Probably looking at the launch sequence of the HTTP server and maybe editing the HTTP request sum. So I'll have to do some more experimenting in the meantime, but until then, I hope you enjoyed the video. Please leave a like and subscribe if you enjoyed it, and until next time, toodaloo.